Hello everyone. In this video, we'll learn about the Lewis dot structures of ionic compounds. So let's start. What are Lewis dot structures? So first of all, in order to draw a Lewis dot structure, we need to know how many valence electron that element has, right? So that we can get from the periodic table. So lithium, for example, has one valence electron. It loses one valence electrons to form lithium ion, right? Calcium, on the other hand, has two valence electron. It loses two to look like a nearest noble gas, right? And it makes Ca2 plus ion. Nitrogen has five valence electrons and it has to gain three in order to look like the noble gas. So it forms N3 negative ion, right? And sulfur, having six valence electrons, needs two more and it will make sulfide ion, right? So everything that I wrote here, you can use your periodic table to see how many valence electrons are there and what kind of ion would that element make. So whenever we have to draw Lewis dot structures, first step is you need to draw the valence electrons for that element, right? For example, potassium has one valence electron, right? Since it's in group 1, it has only one valence electron. So we can draw one dot. So this is the Lewis dot structure of potassium atom, right? So these are all atoms, Lewis dot structures of atoms. And bromine, since it's in group 17, it has 7 valence electrons. So we can write down the symbol of bromine and put 7 dots around bromine. So 2, 4, 6. We usually draw the dots in pairs, right? And then 7. So this is the Lewis dot structure of bromine, right? Now, calcium has 2 valence electrons. So we can either draw 2 dots like a pair, or we can draw 1 dot here and 1 dot here, right? So it does not matter where you draw the dots, right? As long as it's a neutral atom or single atom, right? So we just can adjust the dots when we are making bonds, right? And oxygen has 6 valence electrons, so we can draw 6 dots like 2 in pairs and then 1 here and 1 here, right? Or maybe we can make 3 pairs of valence electrons around the oxygen atom. So imagine there's a square around the atom. We place the dots in pairs or single dots on the sides of the square. Okay? So this is how we do the valence electrons and draw the Lewis dot structure of single atoms, right? Now let's learn how we draw the Lewis dot structure of an ionic compound. How do I know that KBr is an ionic compound? There's a metal, which is K, and K is a metal and it always forms a cation. So as long as you can isolate a cation and an anion in the molecule or in the formula, it means it's an ionic compound, right? The only ionic compound that is all non-metallic is ammonium. So K is a metal and it is going to make a cation. So K forms K plus, right? We know that. Potassium loses one electron to look like noble gas. And then Br has 7 valence electrons and it needs only one to make an anion, so it makes Br1 negative anion, right? So it's always give and take. Ionic bonds are always formed by give and take. Metal loses electrons and the non-metal or the anion that is formed by the non-metal, it gains electrons to make an ion, right? Since potassium has only one electron, valence electron. So this is potassium. And then if I draw the Lewis dot structure of bromine, bromine has 7 valence electrons. So this is how bromine looks like with 7 valence electrons. Now when I have to draw a Lewis dot structure, so this potassium atom gives off its valence electron to bromine. And then bromine makes an anion, negatively charged anion, and potassium makes a positively charged cation, right? So once the potassium atom has lost its electron, it does not have any valence electrons. It had one and it gave it to the bromine. So we'll just put potassium in square brackets and then write the charge on the top of the square bracket. So this is a convention how we write the ions, right? The ion with the valence electron, the symbol and the valence electrons are always written in a square bracket, no parenthesis, and then the charge goes on top, right? Now let's look at the bromine atom. So bromine had 7 valence electrons of its own. Does not really matter where you draw the dots, right? It has to be around the atom. So now bromine had 7 valence electrons. I'm kind of drawing the 7 valence electrons of bromine in blue, right? And then just to show you that it gained another electron from potassium. So potassium had 1 electron. It gave it to the bromine atom, and then bromine turned into bromide ion, right? So this is the Lewis dot structure of bromide ion. So again, I'm going to put the structure in parentheses. So what goes in, in square brackets, what goes in square brackets, we write down the symbol and all the valence electrons that the ion has now. And since it gains a charge of 1 negative, so we write 1 minus on top of the square brackets. So this is the Lewis dot structure of potassium bromide. Okay. Now let's do the Lewis dot structure of lithium nitride, right? The cation is lithium and the anion here is nitride ion. So this is nitride, right? And then lithium ion, right? So now let's see how we draw the Lewis dot structure of lithium. So lithium is group 1. It has only 1 valence electron. So that is lithium atom, right? Nitrogen atom, on the other hand, is in group 15. So it has 5 valence electrons. So 1, 2, 3, 4, 5. Remember, we can place the dots around the atom, right? The way we want to. So nitrogen has 5 valence electrons. How many more does it need to complete its octet, or 8 electrons? It needs 3 more to complete its octet. Right? Now, lithium atom can only give 1 electron, right? So it will take 3 lithium atoms to donate 3 valence electrons to 1 nitrogen atom. And you can actually see from the formula. So we need 3 lithium atoms, and 3 lithiums will give 3 electrons to 1 nitrogen. So I'm going to write 3 lithiums, right? And let's draw the electron in lithium in red. So we have 3 lithium atoms, right? So once each lithium donates its electron to nitrogen, nitrogen gains 3 and each lithium loses 1, right? So the structure kind of looks like lithium, the cations, after it loses electrons, does not have any valence electrons in the actual shell, in the original shell energy level. So lithium gains a charge of 1 plus, and then we need 3 lithium atoms. So I'm going to put the subscript. We always draw only one cation and one anion and use the subscripts if we have multiple cations or anions in the formula. So in the formula, we have 3 lithiums, right? So we have to write the subscript 3 here. And now for the nitrogen, nitrogen originally had 5 valence electrons. 1, 2, 3, 4, and 5, right? And then it gained 3 more electrons, the red ones, from each of the lithium atom. So here, right? So I drew the red electrons. So these are the electrons that nitrogen got from lithium. Lithium lost electrons. It loses electrons and forms a cation, whereas nitrogen gains electrons and forms negative ion, right? So we will have to put a charge of 3 minus because nitrogen makes N3 ion, nitride ion, right? So now we have these two. So this is the Lewis dot structure for lithium nitride. So let's do one more example. So let's do magnesium oxide. So this is magnesium oxide because the cation, sorry about the spellings, magnesium oxide. Okay. Magnesium atom is in group 2. So it has 2 valence electrons, right? Whereas oxygen atom is in group 16 and it has 6 valence electrons. So I'm going to put 6 dots around oxygen atom. So oxygen has 6 valence electrons and magnesium has 2 valence electrons, right? So these are the atoms, neutral atoms. Now magnesium can lose 2 electrons and look like the noble gas, right? It can look like neon with 10 if it loses 2 electrons. Oxygen, on the other hand, has 6 valence electrons, needs 2 more to look like neon, right? To complete its 8. So what happens? Magnesium gives off its 2 electrons to oxygen. Okay. Oxygen needs 2 and magnesium can give 2, right? So there are no subscripts in the formula. When the cation and anion have the same charge, there are no subscripts, right? So once magnesium loses 2 electrons, we can just write magnesium. So this is the atom, right? And then after losing 2 electrons, it gains a charge of 2 plus. So this is magnesium. Whereas oxygen atom, after gaining 2 electrons, now has 8. So the brown ones are the original 6 electrons of oxygen and then 2 more that it gained from magnesium, right? Since oxygen gained 2 electrons from magnesium, it will have a charge of 2 minus. So this is the Lewis dot structure of magnesium oxide. There are no subscripts because both charges cancel out, right? So we will still have to write the ions in square brackets and put the charge on top, and then show the valence electrons for the anions. Hope that's helpful. See you in the next video on covalent compounds.